So what happened here is that so this whole item it actually just create this whole entirety of the tree. So what happened is that, okay, I read 1, so okay, I then draw a 1 over here, and then obviously the next operation is like the next item, so it's like 2. So if you were to actually simplify it in a sense, is that operation Z is that we always go by the left. As you can see, the moment I go from here to here, it's always starting from the left. And obviously before operation Z is that you know that you're on the root item, but just that after the operation X is that you go on to the left node, which is over here. So for the similar case is that the moment that you go over here, you have the N, you straight away go towards the left again. And the thing is that at the same time is that there is some form of like hint, so that within like the scope of like all this operation, there's like some form of hint that is like being produced for us when we are maneuvering around our map. And that is that if you tell me there is a form of like a null value, it indicates that we are going towards the right child. And if it's like because it's either it's a null or there's like some form of like value, if say there's like a value, we just proceed on as per normal case, which is like operation Z. But for this case, since we know that there's no value, that means we can't continue. It will fall under the category that, okay, I guess there's no more deeper roots. So in another words, this is like saying that no deeper item over here. And for this one is that if there's like a value, we continue, right? Obviously. So yep. And so after going through here, we get another null. So it's like 2 nulls at the same time. It's like we have a second null. It means that this item is like a leaf node. And when it's like a leaf node already, you then proceed on to the next item. And so far I only have created the left side, and it seems like we have reached the leaf node already. There's nothing for me to continue at this junction, so I proceed on to the next right side from the root. And operation W is like saying that if I got a base case, which is for this side, that means that we can proceed to right side. Which we do, and then we go on to actually proceed to operation N, which is going to the right. Put in the 3, cool. And then we try to go towards the left side. There's a value, 4, cool. We try to go left deeper again. And then it's an N, obviously. And whenever it's N, we fall under the category of going towards the end portion, which is that there's no deeper roots, so we go to the right child. And it's an N again, so we are falling under this category of saying that there's a second end, and that if there's like a second end, we leave the node. So we leave this area and we proceed back to the subroot. So here it's so much more about like proceeding to the subroot. And we go to the subroot and we go towards, obviously we visited the left side, so we'll go to the right side. We have a value of 5. We proceed to the deepest of the left side, it gives you an end, and then give a second end, and then we consider this to be a leaf node already, which is a base case. So if we have like operation O, we have reached all base case. It basically means that it's time to actually exit this whole entirety place, and we're sort of like done with the whole loop. And so you can actually tell that like with the hint that we've been given over here is that it acts as a form of like operation, as you can see, is that when you have like a NOR, it means that you got to visit the right child, and you reach a second NOR. It indicates to you that this item is the base case of a leaf node for you to proceed to the next item. And I mean, obviously, if there's the normal case of like you entering to a normal value, you can proceed with like the normal operations. But when there's a NOR, you perform the special operations right over here. So in other words, I feel that here is so much more about the special cases, and here is like the normal cases where you just proceed, keep on going towards the DFS route, which is always going towards the left until you reach a special case. Then you do the special moves. So I mean, the core objective of the Leetcode problem is like really fundamentally all it's asking is that by using this serialized code, how are you actually able to actually create a script, create the tree like from scratch. And obviously we can see that it has like the ability to do so, and we were able to actually go through all the single operations and be able to like finish up doing the whole tree. And the spell like we've been casting a lot is like all this like multiple operations within each node. So it definitely falls under the category of DFS the moment we talk about this. And this DFS thing is always operated by a character tree per se. And if you were to see from like the rulebook, whatever they're asking is that they want you to create a tree, right? Fundamentally. And I mean, if they want to create a tree, you got to definitely intuitively you're gonna cast the character tree. I think that we also can use the brute force to fight against the main character. And like when I look at this whole item list, I just feel that brute force, if it's like a F operations, is that you will enter here, you will enter here. In my opinion, I don't really think that brute force will be able to actually identify like where to go. It may just cover like the breadth of as such, and but what you really need is operation G of the three operations of all these different operations, where you are able to actually enter into here, and then enter into here. And when you enter to here, it will tell you that this is like no more deeper road, and that you enter here. But for brute force operation F, it enters here, maybe say it enters here, it doesn't know like this is the end route, and it just doesn't know where to go. Maybe you will just go here and here, and whatever the Leetcode is trying to ask you, you won't be able to actually fulfill it. So I mean, you got to have like the operation G, where you know what the hell are you going, and the moment you reach until here, you know that this is like a end, that you move on to like the right child of this subroute. Yeah, so with that, I think using operation G to actually fight against brute force, that's how I'm gonna actually argue about it. And whatever we're seeing over here in terms of like the operations, it just you can actually feel that it's obviously there's a lot of like maneuver map, and it involves a lot of like smart movements. So if say that it reaches like a special case, it know how to actually remaneuver its system. So I feel that fall under this category. And a lot of times like trees, DFS is able to actually carry out these spells. And also like I mean the Leetcode question, like the one of the rule book, I just feel that it's giving you one singular line, and they want you to actually create an item using this. So it's a very much of a move that a lot of like trees are able to actually carry out such moves, where you have like a single line of like items, and you just be able to actually carry out different number of like operations within like each single node, right? And this is one of like the spells that trees are capable of like doing. I mean, one more thing to note is that, as you can see, one of the spells that we talk about is like maneuver map special smart maneuver. It comes down to this: the moment you talk about like being smart, is that you can identify whether is it like normal or special case. So if it's normal, it will always keep on proceeding down leftward. And what makes this smart, what makes it so special, is that the moment it reaches n, it know how to actually react to it, and actually do a reroute of a direction and come to here and go back towards here and what not have you. So this involves a lot of like a smart maneuvering system. And what I find really fascinating is this, that it does know somehow where the root is. So I mean, like the first node is like the root node. Okay, cool. We come to here, go to left. Like obviously double end means it's like the end of like the place, and obviously we have like visited the entirety of the left side, so we proceed on to the right side, and then we try to go as deep as possible. And obviously double end, it identify that this place is going towards an end, and it's through this visualization of like all these current items, that all these existing items, that I know that okay, what's remaining is actually on the tree right child that I have not like been proceeded so far. So I go towards this area and I actually finish up over here as well. It's like I know when here is like, if you were to see every single operation, is that we do know that here is the root, we do know when here ends, and then we know when to actually proceed on to the right side of things. So like the closest place of here of this node is actually the root node. So we use like for this guy's perspective, its root node is over here, so therefore it comes to here and then proceed on. So it's like using your nearest neighbor's root, which is this one, and sometimes it will be maybe the main root, which is for 2, the nearest root is the main root, and you proceed towards the 3. But for this one, it's like a subroot. Sometimes it's a subroot, you go to here. Sometimes it's like the main root, you come to here. So if you were to see, is that this guy, it doesn't have like a vision whether like the guy over here is like a the main root or the subroot, but it continues to proceed, and it will still be able to like fulfill the criteria to building the whole tree. I think that's one of like the beauty facade that I see in this whole operations when it was being carried out. Like this guy, he doesn't know that his neighbor root, is it like a subroot or main root. This guy may be over here, and he will do the same thing, and he will do the following operations. But obviously this guy is not obviously attached towards the main root, it's attached to the subroot, and it still start to actually carry out its operations. So like in fact, like both these guys, they don't really have like eyes whether they are subroot or main root, but doesn't matter, because at the end of the day they don't need to know, because you will eventually be able to like build the structure based on whatever rulebook is asking you to do. So it's a simple logic, but it can fulfill to build the whole tree from based on this rulebook, whatever is asking. But if you were to ask me that if these guys know that who their roots are, is it a main or sub, I tell you they don't. But even though they don't, they are still able to actually fulfill the criteria. I guess that's the thing that I want to drive across. And one special thing is that they know when is the base case. Obviously, when there's like a double no, is a base case for this item, and a base case for this item. And how do you know that you don't just end here? It's because that there's like a chance that you still can create nodes, because you still can create a right side node for this one. Obviously we know that like this item, it has created its right root, so it doesn't matter. But here at least, like we know that each of the roots must create the left and the right, must cast the spell split. This must cast a split, which is creating the left child and right child. Same for this one, left child, right child. Every item must create a split. When we reach a base case over here, we ask whether like is my neighbor root have finished casting the split. Obviously it hasn't, so it still haven't finished the loop yet. Even though we reach a base case over here, we straight away ask, is our neighbor finished casting out the split? He hasn't. There's still a right child. We proceed, and we come to here, and then we say that, oh, this is another base case. We ask like maybe the neighboring root, that has it finished casting the split? Obviously it did, and therefore it really returns everything, that everything is base case, and return back to the system because everything has like ended. Well, that's like a deep analysis, I feel like. So I mean with it, everything comes to an end.